And welcome back, students. We are delving now a little bit more into the motherboard. Let's start talking about some of the basic components that comprise the motherboard itself. So getting started, recall that we've mentioned the motherboard is the main printed circuit board for the computer. And we've examined a bit of information regarding the ATX style motherboard. Now we're going to look at the different components that typically comprise the motherboard. Alright, the first thing we'll talk about is expansion slots. Now, the first thing we're going to talk about are ISA slots, which are the oldest expansion slots in the history of motherboards. These are found in the old AT boards, and they are identified by their black color, as you can notice here in this diagram that I have here. Now, conventional display cards or sound cards were typically installed in these slots. The full form of ISA is the industry standard architecture, and it is a 16-bit bus. This term might sound familiar for you a little bit if you took computers and logic. We talked about ISAs there. Now, ISA is still used today for specialized industrial purposes, but it has been replaced in consumer devices by PCI. So this is an older style. We're just merely mentioning it because it is still kind of in use today. Otherwise, we really wouldn't talk about it too much. All right, expansion slots. Continued. Next up is PCI slots, or peripheral component interconnect. These are one of the most important motherboard components today and are vastly used to install add-on cards on the motherboard. The PCI supports 64-bit high-speed bus, and it has been largely replaced by the PCI Express type slots. Here's our PCI Express. Just to kind of give you a comparison, you can see the difference here between a PCI and then PCI Express. All right, there's a PCI X1 and X16. So PCI Express, also known as PCIe, is the latest and fastest component of the motherboard to support add-on cards. It supports full duplex serial bus and has several form factors. We'll look at two of them. The first is PCI Express X1, which is the slot for modern expansion cards such as sound cards, network cards, so that's things like Wi-Fi, Ethernet, Bluetooth, connector cards, so things like USB, FireWire, eSATA, and certain low-end graphics cards. Now, PCI Express X16 is the slot for things like discrete graphics cards and high bandwidth devices such as top-end solid-state drives. So anyone that does their own building PC and they put in their own graphics cards, they're taking use of this PCI Express X16. And so you'll usually have several of these X16 slots. In fact, you won't have PCI slot, you'll have X16. It'll probably like 3 or 4 of these and maybe 1 or 2 of the X1, just depending on how your ATX board is set up. All right, one last expansion slot to talk about is the AGP, or the Accelerated Graphics Port. It is specifically used to install a graphics card. AGP runs on a 32-bit bus, and both PCIe and AGP can be used to install high-end gaming display cards. You typically don't see AGP used as much, but it is still kind of used sometimes. But most of everything now is PCIe. All right, next let's get into one of my favorites, which is RAM, or the memory slots. DIMM slots, or the double inline memory module, are the latest RAM slots which run on a faster 64-bit bus. The DIMM that's used on laptop boards are called SODIMM. I know, it's kind of like a pun, SODIMM. But ignoring that, we just need to mention lastly that DIMM is the replacement for the older SIM slots, or single inline memory modules. Now, I'm not going to talk too much about RAM here, because when we actually look at RAM, when we actually talk about that, we'll talk a little bit more about what those DIMM values mean, what's the different things that go on with putting the memory in there. So we'll come back and we'll look at memory more in depth in its own lesson. All right, the CPU socket. Another vital component is the CPU socket, which is used to install the processor on the motherboard. The processor chip is identified by the processor type and the manufacturer. This information is usually inscribed on the chip itself. If the processor chip is not on the motherboard, you can identify the processor socket to find the processor that would fit in there. And again, this is another thing that when we talk about the CPU, we'll look at with a little bit more detail. All right, next up is the BIOS. Also known as the basic input-output system, it is a motherboard component in the form of an integrated chip. The chip contains all the information and settings of the motherboard, which you can modify by entering the BIOS mode from your computer. BIOS is essentially the link between the computer hardware and software in a system. Now, BIOS is what's known as read-only memory, which consists of a low-level software that controls the system hardware and acts as an interface between the operating system and the hardware. This system BIOS is a ROM chip on the motherboard used during the startup routine, so during your boot process, that also checks out the system and prepares to run the hardware. So this little chip right here is what does all your helps run all those hardware checks. And we kind of talked about this a little bit when we talked about the ATX, but just kind of brings that back again in full circle. All right, your CMOS battery, very important. This little guy right here, don't remove him. Known as the complementary metal oxide semiconductor, this battery is a 3.0 volt lithium type cell. So it's not your regular alkaline battery, that's a lithium battery. Now the cell is responsible for storing information in BIOS, such as your hard disk drive types, your CPU information, the RAM size, date and time, serial and parallel port information, plug and play information, and power saving information. So this little guy actually does quite a bit. Alright, those power connectors. We've talked about these briefly before, but let's just talk about them again since they are on the motherboard. As discussed in our last lesson, there's typically a 24-pin connector for the motherboard. And the ATX 12-volt power connector also connects to a 4-pin cable of a power supply, which supplies power to the CPU. Now, some of your BP CPUs might have a larger need than a 4-pin. They might require an 8-pin. Just kind of depends on what your CPUs looks like. Now, additional power CPUs may power the CPU or case fans. So that's sometimes it's not necessarily the CPU, it might be the fans itself. All right, we need to talk about the IDE connector next. And this is not something you typically see really anymore, but the integrated drive electronics connectors are used to interface disk drives. The 40-pin male connector is used to connect IDE hard drives, and the 34-pin male connectors connect to floppy disk drives. So you can see that, all right, this seems like an old technology because who uses floppy disk anymore? But it is, if you're ever one of those kind of people that does things that might use those older technologies or like an older IDE drive rather than a SATA powered one, this is the connector you would use. And as I mentioned, these have been largely replaced by SATA connectors. SATA is just a faster and better connection. And here's our SATA connector. These little blue modules right here. Boom, boom, boom. There's 4 of them here. The connectors, which are known as Serial Advanced Technology Attachment, are 7-pin connectors to an interface in the latest SATA hard drives or optical drives. So that includes, your traditional hard drives, maybe a solid-state drive, maybe optical drive would be something like a DVD drive or a Blu-ray drive. Now, compared to your IDEs, these are much faster. You'll see that the connections on them, they support like up to usually like 6 gigabits per second. So that's a pretty good connection speed compared to that of what you can get off an IDE. All right, we need to talk next about chipsets. Now, chipset is a group of small circuits that coordinate the flow of data to and from a PC's key components. A chipset controls the data to and from hard disk and other devices which are connected to the IDE channels. The computer typically has 2 main chipsets, the north and the south bridge. The north bridge, also known as the memory controller, is in charge of controlling transfers between the processor and the RAM, which is why it's located physically near the processor. Now, this motherboard component is not really present. I mean, you might occasionally see it, but it's typically no longer present as a lot of those features have been now integrated into the CPU itself. The south bridge, though, still exists, and the south bridge, which is also known as the input-output controller or expansion controller, handles communication between slower peripheral devices. It is also known as the ICH or I/O controller hub. This chipset allows the CPU to communicate with PCI slots, PCI Express, SATA, USB, Ethernet, and onboard audio. All right, 2 more things to talk about. First is the cabinet connectors. These are also known as the front panel connectors. The cabinet which the motherboard is installed has many buttons that connect to the motherboard. As you can see, there's all these little pins up in here. There's front panel USB connectors. They typically connect to USB 2.0 or 3.0 ports at the front or top of the computer case. Now, some of the other common connectors that you'll see in here are things like your power switch or reset switch, front USB, which is kind of where I mentioned right here, power indicators, which are LEDs, or a HDD LED, so it's an LED to indicate for your hard drive. All right, here's the last one, which is the I/O interface connectors. These are also known as the back panel connectors and ports. We already talked about the front panel. This is for your back panel. These are connectors and ports for connecting the computer to external devices such as display ports, audio ports, USB, Ethernet, and PS2 ports. And we'll talk more about these different kind of connectors later lesson. But for now, this is all you kind of need to know with that. And that concludes our notes, folks. Until next time.